I'll share my screen share. Wait.
Okay.
Is my screen visible, sir?
Yeah, I think it's loading. Yeah, visible. Continue.
Yes, sir. My topic is K-maps. K-maps, nothing but a Karnong maps. Firstly, I'll present it. Hmm. First, quick overview. K-maps is a grid-like diagram that represents all possible values of input variables and their corresponding output values in truth table. Firstly, why we use this K-maps? To simplify the Boolean expressions, to design more efficient digital circuits, to reduce number of gates and components in a circuit. First, do you still remember this Boolean algebra? Here, some expressions is there. Using truth tables, we can build equation, but we applied some theorems. After applying theorems we can get simplified expression. Using k-maps directly we can get simplified expression. Here we see here I consider one equation xy plus xy bar. After simplifying after applying some boolean boolean algebra laws, it gives x. First xy nothing but a x equal to 1 y equal to 1. Next xy bar nothing but a x equal to 1 y equal to 0. Mm, After applying and gate, it's nothing but a SOP form. So after applying, uh, the result is 0011. uh, or after simplifying, applying this the after simplifying also it gives a same result. So it's better to simplifying expression is better. Hmm. Uh, this equation is very small, so we can easily simplify it. Here, suppose more number of variables present here. Here, four variables present. It's We can build using truth table. We can build equation using this truth table. But it's very time taken and it's very difficult and apply so many laws. Using k-maps we can easily identify easily solve this easily get this expression. Hmm, Before proceeding k-maps we have to follow some rules. First one is a adjacency. Adjacency nothing but a for two terms if there is change across one variable only then their two terms is called adjacent term. Next, grouping should always be done in power of 1 or 2 square 4 etc. Next, single minterm can be grouped multiple times. Each minterm need to be grouped at least once, and it should be grouped multiple times only for the purpose of simplification. Here, two variable k-map. Two variable k-map nothing but four cells present, two square. Four cells present. Here, zero is a m naught. It's a min term one. Next, zero one m1 min term two min term min term 0, min term 1, min term 2, min term 3. It's a truth table representation. Here, right side, it's a k-map representation. Hmm. Here, clearly, it's a 0 0 means here 0 0 means m naught is high. Next 0 1 means m1 min term high. 1 0 means m2 min term 2 high. Next 1 1 means min term 3 high. It's a min-term identification. Suppose here I include some expression m1 plus m2. M1 nothing but a 0 1 plus 0 1 plus 1 1. After applying this, after adding, we get this 0 1 0 1. It's a simplified here. It's a our simplified expression. After applying some law, we get simplified expression using k map. See, m naught we can represent like this, and m1 represent like this. After combining, uh, after combining the combining, output is coming like this. Here 0 0, m naught is 1, and m1 m1 also 1. Yeah, I already told grouping should be always done in power of 2. See, here I grouping power of 2. 2 power 0 means here 2 power 0 means 1. Here 2 power 0 1. Here 2 power 1 means 2. Here it's a simplified expression for m naught x1 bar into x2 bar plus m1. A simplified expression is x1 bar into x2 bar. Next, after combining, the simplifying expression is x1 bar. It's a I already told grouping rules. Mm. Two variable came up discussed step by step. Here I saw one example: 0 0 it gives 1, 0 1 it gives 1, 1 1 0 it gives 0, 1 1 it gives 1. It means min term 2 is not present, remaining all present. Here I derived using I applied SOP technique only. Using POS also we can simplify. Here see, m not and m, here m2 is 0, remaining all three are present. See, 0 0 1, m not value 1, m1 value 1, m3 value 1. Next, how to group? First, these m naught and m1 group first, and next m1 and m3 group next, or vice versa also same. M3 and m1 first, or m1 and m1 and m naught also same. See, first group m naught and m1, next m1 and m3. Next, now we have to try write equation. See, x1 bar. Why it's coming x1 bar? X2 transition, x2 nothing but this vertical line. It transition between 0 to 1, 0 to 1. I already told I used SOP, x2 dot x2 bar, nothing but a 0. So it's a the red one is coming to x1 bar. Next, this green one is x2, because x1 trans 0 to 1, x1 dot x1 bar is 0, so it's coming to x2. Next, hmm, here I already discussed. Next, first these are some valid groupings. Valid groupings. Here, sir, the M naught and M3 diagonal elements, it's a not valid grouping. Only vertical or horizontal grouping are possible. Hmm. Here also I discussed. Here I used gray code because it follows adjacency. Here it's 0 0 0 1. Next, actually 1 0 came, but 1 0 will come. But I wrote 1 1 because it follows. Because of following adjacency, we can designing like we can like this. See, 0 0 0. Next, 0 0 1, 0 0 1 0 0 1 1. Next, see, in these two steps, 0 0 0 0 0 1, only one bit change. It means these are adjacent. Here, suppose we are writing a 0 1 after 0 1, we are writing 1 0 0 1 1 0. These are not adjacent because two bits are changing. See, here also one bit only changing. So these are two adjacent. These are all two adjacent. Here, see, 0 1 0 and 1 1 0. These two are adjacent. Next, 0 1 0 and 0 1 1. These two are adjacent. Next, 0 1 1 and 1 1. These two are adjacent. Next, 1 1 0 and 1 1 1 is a these two are adjacent. I already told grouping should be always two powers. So I grouped like this. Hmm. The M naught and M1, M4, M5 also adjacent because see 0 0 and 1 0, one bit only changing. So these are adjacent. See 0 0 1 and 1 0 1. Here also only one bit change. Gray code follows adjacency, so I used here. I used gray code. Here, see, these four neighbors differ in the first and last bit. They are similar to their middle bit, so we can group that four bits. Mm, See, valid groupings. The vertical M naught and M1 is a valid grouping. M2, M3, M6, M7, M4. These are a valid groupings. These are M naught, M2, M2, M6, M6, M4 like this. M naught, M2, M6, M4. We can group. See, I draw, I think. Here, M2, these are valid groupings. I already told diagonal groupings are not valid. I told grouping should be always be done in power of 2. So it's a 8 times 2 cube. So we can group. If this diagonal grouping is invalid. Suppose we are doing this kind of grouping, definitely we will get wrong answer. Here it's some see mm, 1 1 and min term min term, min term 3 and 4 present. Min term 3 and 4 present and 1 present. One 4 okay. Mm. See, here x3 nothing but a first seeing my cursor, saw my cursor. Here x3 is constant. X3 is constant. Here 1 1 1 0. These two are adjacent. Here x1 is constant. Nothing but a x1. But here I changing x2 1 to 0. Here transition happened. It means x2 to x2 to x bar it's a 0. So x1 dot x3 bar 1 x1 to x3 bar 1 expression. Next, these two see, yeah, here x3 value is directly 1 and which bit is we saw which bit is changing. Here x2 is constant and x1 is 0 to 1 transitioning, so we can eliminate that bit. So x2 bar dot x3. It's a SOP logic, nothing but a AND or logic. First, we are performing AND operation. After we perform or operation. Mm, Here, see, these four all are adjacent, so we can group only x3 bar expression present only. And next here, mm, here. Here x3 is transition. Yeah. In x3 transition happens 0 to 1, so we can eliminate x3 term. So yeah, here clearly it's visible x1 and x2 bar. It's a expression. Next, Next, variable K map also similar to three variable three K maps. See here M not M1 M2 here 1 1 1 0 0 0 0 1 1 1 1 0. Uh, Following adjacency, we can design like this. So M1, M2, M3, M4. Here after M6, M12 is coming. M3 after M3, M15 is coming. After M14, uh, M14 after M8, M9, M11 after M10. Mm. See, first now will these m naught and first column and last column, these two are adjacent, and second and third column also these are adjacent. So we can group it. It's a similar to three variable k map. Efficiency rules. Here see. Mm, First this see my cursor here, constant x3 bar dot x4, and here constant value is x1. um, X2 is variable, so x3 x1, these x1, and x3 bar x4 one expression, end operation. After these four are adjacent, so we can group. Here x4 is transition, so we can eliminate that x4 term, and 0 0 x 0 1 x1 also transition happened, so we can eliminate that term. So in this case only two variables present. So first one, 0 0, here constant 0 is present, 0 0 x2 bar, and here x2 bar dot x3 plus these x1 x3 bar x4. We can group like this also. We can group like this. Mm. After limitation of this k map becomes a complex for greater than four variables. Using vem method, we can vem nothing but a what is that variable variable entered mapping. Using that method, we can solve the this. That's it.
Yeah, yeah, good, really good, Pradeep. Yeah, so I will introduce you, Pradeep. So Pradeep already attended some exam like NPTL exam. He secured all India level some good rank with silver medal. Okay, so he has very good technical knowledge and studying in triple IT. Okay, generally triple IT means they have to get good marks in a 10th class, like I think in district wise. Okay, even Ashita, first person, she also from triple IT. Okay, so Pradeep, you have very good technical knowledge, not only theoretically, conceptual wise. You are more strong in coding, even more strong in coding. Okay, so keep on, try
Yes.
to keep on like this in English only. Someday you will become more better. Now it's good, better, so that fluency is there. That fluency is there, and when you, I will give you more presentation. So when you keep on talking, it will become more better, like a experienced present, like a teacher or trainer. You will become like that, so that technically, presentation wise, orally, everything you will become good. Okay na? And the,
Yes, sir.
yeah, the content you collected, prepared, this really standard content. When I seeing that content, I remembered one thing. Some few days back, I read one story. One guy, he answered the maths paper, but that university professors unable to understand that answers. So that paper was sent to some Cambridge University, foreign. So they corrected it and they understood the standard of this guy, and they offered the seat in Cambridge University. Okay, but that guy did not went to that foreign because he don't want to leave her mother or something. He want to take care, and at home at a village only, in his village he started training, and some students like free training or paid, I don't know, but he started training in his own village, and that students, I think all students or some of the students, I did not remember, they got seats in IITs after the training. Maybe it is IIT JE or something. Okay, so like that you also have some good standard technical knowledge. Your PPT content is
Yes.
indicating that. Okay, good. Maybe that
Yes, sir.
content yeah, that content, that slides may not understand by everyone, but the point is you understood and you prepared so first that is important. So you understood, you have that clarity, you have that standard. Okay, maybe others also, if they read again and again, if they go through again and again, they can understand, or some people who have idea, they can understand easily. Okay, good, anyhow, very good, good. Yeah, now,
Okay, sir.
yeah, yeah. Now we'll give chance to Vaishnavi, then Sirisha.